In this video, we will be covering how to use the Hamilton apportionment method. So there are really two methods to doing the Hamilton method. Either one is perfectly fine. They will end in the same result. But step one for method one is going to be calculating each state's standard quota. And of course, states can be anything. These are just the people or things that we are giving our seats or whatever it is that we are dividing to. Step two, we're going to find the standard quota and we're going to round this down to the lower quota. So we're always just going to chop the decimal off. Doesn't matter if it's 0.5, 0.6, 0.7 or above, we're going to chop the decimal off and we're just going to keep the whole number in the front. And then step three, we're going to give extra seats out to states with the largest decimal value. So we're going to ignore the front number or the whole number at the beginning, and then we will be basing it completely off the decimal at the end. Let's go ahead and dive into an example. So let's take a look at this example. Richard has 3 kids and 13 candy bars, and he wants to base the amount of candy bars each kid gets on the amount of time that they spent studying. So John spent 64 minutes studying, Lucas spent 264, and Nicholas spent 392 minutes studying this week. So the first step of using Hamilton's method for apportionment is going to be to find and calculate the standard quota. So the first step of that is going to be finding the total number of minutes all 3 kids spent studying this week. To do this, we will just add up the number of minutes spent studying this week by each student. So John spent 64 plus Lucas's 264 plus Nicholas's 392. And this will give us a grand total of 720 minutes. The next step would be to divide each of these numbers by the total number of candy bars that we will be giving out. So John's 64 minutes spent studying will be divided by 13 candy bars. And this will give us 1.16. Next, we would do the same step for Lucas. So L, and then we would do his 264 minutes divided by 13. And this would give us 4.77. Then we would just repeat this again for Nicholas. So Nick spent 392 minutes studying. And we would once again divide by our number of candy bars. And his total would be 7.08. So from here, I personally like to make myself a chart. It just helps me stay organized. It's not at all a necessary step, and you can organize your data however you prefer. So I will have J for John, I will have L, and I will have N, and then of course we will need a total. So TOT stands for total, and I will need 2 lines. So I'm going to have LQ out here. This is going to stand for our lower quota, and it's going to extend through this way. And then we will have APP for our final apportionment. So the lower quota, once again, is just going to be chopping off the decimal. It doesn't matter if it's above 0.5. So in John's case, we have 1.16. That's easy enough. If we just round it down, it's going to be 1. In Lucas's case, you may immediately want to round this guy up. But when we're taking the lower quota, we're just chopping off the decimal. We completely ignore that it's there. So Lucas will have 4 in this case. And then Nicholas, 7.08. Chopping the decimal off, we have 7. From here, we want to add up the total amount of candy bars that we've given out. So 7 plus 4 is 11, plus 1 gives us 12. If you'll note from the beginning, we were trying to give out 13 candy bars. So who gets the extra candy bar? That's going to be based off of the decimals. So we're just going to look at who has the largest decimal. So John's decimal is 0.16, Lucas has a decimal of 0.77, and Nick has a decimal of 0.08. So of course, Lucas has the largest decimal. We're going to give him an extra candy bar to get to our total. Now we have 1 plus 5 is 6, plus 7 is 13, and we have now given out all of the candy bars. And that's how you do method 1. So this is going to be method 2 of the Hamilton apportionment method. So step 1 of this is going to be find the total population. And all a population is what's being used to divide what we're giving out. So in the last example, we were giving out candy bars, and our population was the amount of minutes that each kid spent studying. Total population was the total amount of minutes spent studying by all three. Step 2, we divide each state's population by the total population, and this will give us a proportion. All a proportion is a decimal. Step 3, multiply each number of seats, which is what we're giving out. So in the last example, this would have been chocolate bars, and we will multiply each of these by the proportion given, and that will help us find our lower quota. Once again, we're just chopping off the decimal on that. Step 4, we're going to give out remaining seats based on the largest decimal. Let's get into an example. So in this example, Tom has 3 dogs and 16 treats, and he wants to give each dog treats based on their weight. So we have Abby, who weighs 87 pounds, Barkley, who weighs 92, and Chelsea, who weighs 21. The first step of this is going to be adding up the total weight of all 3 dogs. So Abby's 87 plus Barkley's 92 plus Chelsea's 21. And that'll give us a total weight of 200 pounds. From here, we're going to want to create our proportions. So all we're going to do is divide each dog's weight by the total weight. So for Abby, we're going to do 87 divided by 200. For Barkley, we'll divide 92 by 200. And for Chelsea, we'll be doing 21 divided by 200. So when we do each of these, we find Abby's proportion is going to be 0.431, Barkley will be 0.485, and Chelsea will be 0.105. From here, we're going to multiply each of our decimals by the total amount of treats. So it's going to be 0.35 times 16, 0.485 times 16, and 0.05 times 16. When we do each of the math on these, we'll find that Abby's proportion is going to be 6.896, Barkley will be 7.76, and Chelsea will be at 1.68. From here, I'll go ahead and put my table back together. So we'll have A for Abby, B for Barkley, and C for Chelsea. And then once again, we will need total. Then on the side, we'll need LQ, once again for lower quota. And then we will need APP for our final apportionment. So we're just chopping the decimals off here. So 6.896, no matter how close we are to 7, we're cutting the decimal off. Our lower quota is 6. Barkley's will be 7. And Chelsea will have 1. Then we'll once again just add up our total lower quota. So 6 plus 7, 13, plus 1 will give us 14. We had planned on originally giving out 16 treats, so that means that there's 2 left to give. So we'll go with the 2 highest decimals. So once again, we're ignoring the front number, and we're just going to look at the decimal. So the largest decimals here are, of course, Abby's and Barkley's. So each one of them will get an extra treat. So Abby will now be at 7 for her final apportionment. Barkley will be at 8. And Chelsea will stay at 1. And this will give us our grand total of 16. I would like to take this time to thank you for watching this video. If you have any other math related questions, please feel free to comment them down below or email them to me at aankrum.tutoring@gmail.com. Once again, thanks for watching, and I hope you have a wonderful day.